Good morning, class. You might recall that in the last lesson, we focused on the trigonometric functions at the top of this page. In the lesson today, I'd like to focus on this integral rule. We have the integral of e to the u du is e to the u plus c. And hopefully this isn't terribly surprising to you. In your differential calculus class, you learned that the derivative of e to the u was e to the u. So if you had e to the 5x, its derivative would be 5 times e to the 5x. So the rule for the integral is similar, but with one notable difference. So let's have a look. Okay, we're gonna start here with this problem. We have the integral of e to the n times x with respect to x, and we must note that n here is a constant. So n is a constant, which means it's just a number. So the derivative then of the exponent n times x would just be n. So we just get a numeric derivative. So this means that the integral ends up being 1 over n times e to the nx plus c. Okay, so again, we're comparing this with e to the u. The derivative of u happens to be a number, the number in this case n. Okay, so we can go right away to this form. And this means if, for example, this is the integral of e to the 5x dx, this would be 1/5 e to the 5x plus c. So the difference being when you are taking the integral of the exponential function, you are dividing by the derivative of the exponent, while when you're taking the derivative of an exponential function, of course you are multiplying by the derivative of the exponent. Okay, so I can just write that here for you really quickly. So if you have e to the 5x and you take its derivative with respect to x, this is 5 times e to the 5x. While if you are integrating e to the 5x with respect to x, this is 1/5 e to the 5x plus c. Okay, so this is how you handle both the derivative and the integral of the exponential function whose exponent has a derivative equal to just a number. In this case, that number is 5. All right, but now we'll go on and look at some more interesting problems, of course. So here we have the integral of x squared times e to the x cubed dx. Now remember, we want to compare it with this integral equation, and that suggests that whatever is in the exponent, we let that equal u. So we practiced u substitution over and over again yesterday with the trigonometric functions. So we use that again today. So u is equal to x cubed. So then what is du? Du is 3x squared dx. And now we take a look here. Of course, this is going to be rewritten. This part will simply be e to the u. So the question is, how does x squared dx compare to 3x squared dx? Well, x squared dx is 1/3 of 3x squared dx. And that means over here, we have 1/3 of the integral of e to the u du. Actually, over here, I was hoping to be writing with blue again. Let me fix that, okay? I know you don't care, but I'm fussy like that. Okay, so we have 1/3 the integral of e to the u du. So we have the exact form here. So we know the integral is equal to e to the u plus c. So we'll now have 1/3 e to the u plus c. And just like with our previous lesson, in the final answer, now you replace u with, in this case, x cubed. And now we have our results, 1/3 e to the x cubed plus c. All right, we'll try number 3. So again, it looks very complicated, but remember, the form we're hoping to use is this, e to the u. So we're hoping to make this some multiple, perhaps, of the integral of e to the u du. So how do we begin? We take the exponent and we set that equal to u. So u is x squared plus 6x minus 2. So what is the derivative of this trinomial? It is 2x plus 6. Okay, and of course we need the differential dx here. So we might want to have a little bracket around the binomial. Okay, so now taking a look at what we have here, this of course becomes e to the u, e to the u. So the question is, how does this x plus 3 dx compare to this 2x plus 6 dx? Well, x plus 3 is 1/2 of 2x plus 6. Okay, if it's helpful to you, you can rewrite du this way. You can remove the common factor of 2. And maybe now that makes it even more evident that here we have x plus 3 dx that happens to be 1/2 of what we have here. So we have 1/2 of du. So this becomes 1/2 of the integral of e to the u du. Well, the integral of e to the u du is e to the u plus c. And then again, last step, replace u with our trinomial. And we have our answer. So, of course, what we're saying is that if you were to take the derivative of this function, you would get back this right here. Okay? Same thing in this one. If you were to take the derivative of this function, you would get back this. And of course that's true because when you take the derivative of the exponential function, you simply repeat the exponential function and then you multiply by the derivative of the exponent. Okay, let's try a next one. Over here, okay? So this one is fairly complicated because yes, we have our exponential function, but we've also got trigonometric functions mixed in just for fun and creativity. Good times, good times. Okay, so let's get started. I think the first thing to note is that the exponential function itself is in the denominator, which is not good. Okay, so we'd be better off bringing this up. So we have to remember that overall it is a power. There is a base, there is an exponent. So we treat it like a power. So when we bring this up, the exponent will change from positive to negative. Okay, so the 4, we can maybe move to the front here. So what I'm suggesting is that we bring this up so it'll be e to the negative sine x dx. Okay, and again, underneath can still be our secant x if we like. Okay, but we can do even better than this. We practiced using some identities yesterday, and what we have here is secant in the denominator. So essentially we have 1 over secant x, and 1 over secant x is cosine x. So it would be better still to write this 4 times the integral of e to the negative sine x times the cosine of x with respect to x. Okay, so now there's no longer any denominators. So in going from this step to this step, we changed 1 over secant x into cosine x. And now we're ready to get started. Again, we're treating this as e to the u. So we start by saying let u be that exponent. We need the derivative of negative sine x. So what is the derivative of sine x? The derivative of sine x is cos x. If you wanted to find that here, remember you look in the right side for derivatives. So here's sine x. So if I read this to the left, I can see the derivative of sine x is cos x. So this means the derivative of negative sine x is negative cos x. Okay, so now we have du correct. So now let's take a look at our original integral. Of course, the 4 will stay where it is. The integral sign will remain. We're gonna take this and make it e to the u. And now finally, is this exactly du? Well, not exactly. It's the negative of du. So this part becomes negative du. This part is e to the u. Okay, so it's going to be therefore negative 4 times the integral of e to the u du. Okay, so this again is the negative of du. So that negative 1 factor multiplies by the 4 out front. And now we have this integral to evaluate. The integral of e to the u du is of course e to the u plus c. And in our final answer, we will replace the u here with negative sine x. So negative 4e to the negative sine x plus c is perfect for our final answer for problem 4. Okay, let's have a look now at number 5. Now, what makes number 5 different? Well, I would say that it's the presence of 2 exponential functions. Okay, so now again, this is when we remember, essentially they are powers. So we can use our laws of exponents to simplify this before beginning. We have powers of the same base. The base is e. This shows division. So what do we do when we are dividing powers of the same base? We subtract exponents. So we can do that here. This becomes e to the 3x plus 1 minus x. Okay, so we take this exponent and we subtract this one from it. Well, that is the same as e to the 2x plus 1. Okay, and now we're all set to continue. Now, we could say, you know, u is 2x plus 1 and continue along with that. Okay, however, we did see, oh wait, sorry. This is our sheet for today. However, we did see in question 1 that when the derivative is just a constant, we can simply go to this form immediately. Okay? Just like this, the integral of e to the 5x dx is 1/5 e to the 5x plus c. So this is the very same thing because the derivative of 2x plus 1 is simply the constant 2. So we can do this. We take 3 and it would be multiplied by 1/2 e to the 2x plus 1. And then, of course, we remember that this is a definite integral. Okay, so in integrating this function here, because the derivative of 2x plus 1 is just the number 2, we can go immediately to this result here. So now, of course, we have 3 over 2 in front of e to the 2x plus 1. And we're still going to evaluate. The constant cancels every time we have a definite integral. So now we're going to evaluate between these limits. So the 3 over 2 can stay out front. And the first thing we do is substitute a half. So 2 times a half is 1. 1 plus 1 is 2. So we get e squared minus, and now we substitute the 0. 2 times 0 plus 1 is 1. So our answer is 3/2 of e squared minus e. And this we can work out with our calculators. Okay, it's still on radians mode from our lesson yesterday, and that's perfectly fine. So we're doing 3 over 2 times, now I'm going to do e squared minus e to the 1. Okay, so take a look at what that looks like here on the screen. Push equals, and there's our answer. So if we were going to go to 3 significant digits, it's roughly 7.01. All right, so that is example 5. So I think today we'll end up doing 8 examples in total. Let's continue. Okay, here's problem 6. This is pretty involved. We have our 2 exponentials, but they are being subtracted, and there is no exponents law for this case. So there is no way to simplify that. This is a binomial and it's being squared. Okay, so, and this division by 4 is the same as having a factor of a quarter out front. But basically, we want to square this binomial to simplify. So that means taking the binomial and multiplying it. Oops, that's supposed to be an e. I'm gonna get my liquid paper going here, okay? Just get rid of that little mark there to avoid confusion. Okay, There we go. So I'm going to take the binomial and multiply it by itself. So we're going to do first outside, inside, last. Now, when we're multiplying, we remember the law of exponents again. So when you multiply powers of the same base, you add the exponents. So I'm going to multiply e to the x over 2 by e to the x over 2. So this becomes e to the x over 2 plus x over 2. So that's like e to the 1/2 x plus 1/2 x. So it becomes e to the x. All right, 1/2 x plus 1/2 x is x. So that's when you multiply the first terms. Now we go to the outside. Okay, so it'll be subtraction. And the same thing, the base remains e, and now we have to add the two exponents. So the exponents that we are adding now are x over 2 gets added to negative x over 2. So that's just 0. Now I'm going to do the inside terms, okay? And again, it'll be negative. The base remains e. We add the exponents. We are once again adding negative x over 2 and positive x over 2, so we get 0. And now we do the last term, okay? These two are both negative, so we'll have a plus sign here. The base is e, and now we add the exponents. We're adding negative x over 2 with negative x over 2. So that's the same as adding negative 1/2 x with negative 1/2 x. So we get negative x. Okay, e to the 0 is 1. So we have a 1 here and a 1 here. So this now becomes 1/4 the integral of e to the x minus 2 plus e to the negative x. It's a trinomial, right? 3 terms separated by these signs. This is a trinomial. So we're going to simply integrate each term individually now. So the 1/4 remains as the factor out front. And now we do, what is the integral of e to the x? Well, that is simply e to the x, because the derivative of this exponent is 1. Okay, minus, what is the integral of 2? It is 2x. Okay, the derivative of 2x is 2. The integral of 2 is 2x. Okay, lastly, we have this plus sign, and we're integrating e to the negative x. So we remember example 1 today. We simply have to note that the derivative of this exponent is -1. So we're going to have 1 over -1 e to the negative x. Okay, remember problem 1? It was e to the 5x. The integral was 1 over 5 e to the 5x. So here we have 1 over -1 e to the negative x. The derivative of negative x is -1. All right, so this is just a little bit awkward. We'll change our final answer to this. Minus e to the negative x. Perfect. So that's example 6. Okay, a couple more, just 2 more I think for this video. So we're gonna work on this one. Now we've got these square root signs, and we know that for calculus, they're not feasible. So we replace the square root signs with fractional exponents of 1/2. So we might as well begin that way. Okay, I could also push that 6 out front, right? That would have been a nice touch. So it's 3x all to the half. 3x all to the half, because the square root sign is over both the 3 and the x. And, you know, I'm certainly going to call this my u right here. Now, this guy here, we could either leave him down there, but I think we'll find it better to bring it up. So I will push the 6 out front. Okay, and now we'll have e to the 3x to the half. And then when we bring this up, we remember, of course, that the exponent will be negative half. So it's this exponential function, and it's multiplied by 3x to the negative half. And that's the same as division by 3x to the positive half. Okay, so we're going to use this now. And again, a strategy that works many, many times is to call the exponent here u. So let's try that, okay? So what we're going to do is we're going to let u equal 3x to the 1/2. And then we're going to form its derivative. Now, we have to remember the chain rule here. So how do we form the derivative? Well, first the half comes out front. Then we subtract 1 from 1/2 to get negative 1/2. But then we also multiply by the derivative of the inside of the bracket, which is 3. And then, of course, don't forget the differential dx. So overall, we have this 1/2 times 3. We have 3/2 of 3x to the negative half dx. And now, and that's du, right? du is equal to that. Now we come back to this and we write this out using the u substitution. So the 6 remains. This is what we make e to the u, right? So we have e to the u now. And finally, we have to decide, how does this compare with du? Compare this with this. Is it identical? Not identical, it's very close. Okay, but this is equal to 2/3 of this, right? Or in other words, if you take this and divide it by this, you would get 2/3. So we have to think of this as multiplying by 2/3 of du, or you could think of it as dividing by 3/2 and multiplying by du. Like this. So 6 is divided by 3/2. So you're either going to consider it to be 6 divided by 3/2 or 6 multiplied by 2/3. Whatever makes more sense to you. The fact is that this is a multiple of this. This is equal to 2/3 of this. Okay? All right, so now we have it rewritten. What is 6 divided by 3/2 or 6 times 2/3? It's equal to 4. So now we have 4 times the integral of e to the u du. And the integral of e to the u du is e to the u plus c. This is a definite integral, but these are values of x. So we cannot substitute them for u. We have to put back 3x to the half or square root 3x before substituting these values. So now we can go ahead and do it. The 4 can remain out front. And then we're going to do e to the square root of 3 times 12, or square root of 36, which is 6, minus e to the square root of 3 times 0. So this will just be 0. So our answer is 4 times e to the 6 minus e to the 0, or 4 times e to the 6 minus 1. This, of course, is 1. And we might as well finish this off by putting it into our calculator. So 4 bracket, now I want e to the 6, e to the 6, and I can either do minus e to the 0, or I can just do minus 1. Close the bracket, take a quick look at the display, right? And then push equals. And so there's our answer. If I was gonna round this to 3 significant digits, it would be 1,610. Okay, that would be if I rounded to the 3rd significant digit. The 3rd significant digit here is the 0, and the 9 rounds it up. Okay, so that would be to 3 significant digits. And that was number 7. And let us do one more example for today, okay, together, and then there'll be much practice for you as well. Okay, so this is very different because even though we have one exponential function here and one here, we can't simplify this because this exponential function is part of this binomial and it has this outer exponent, right? Okay, what we might want to do is bring this guy up. So let's start with that and then see what kind of strategy we can use. So when I bring this up, of course I can put it either at the front or at the back of this binomial here. So, and again, if I bring this up, following the rules of exponents, it becomes e to the negative 2x. All right, and now we're sort of like, oh gosh, what do we do now? Well, this is when we call the inside of the bracket u. And we used that strategy in our last lesson. And also when you learned how to integrate power functions, that was always the rule. The inside of the bracket is u. And we'll see that that will work here, okay? So u is 1 plus 3 e to the negative 2x. If that's u, then of course this will be u to the 4. All right, what will du be? Well, du will be the derivative of this. So it's 2 terms, okay? It's a sum. So the derivative is also a sum, but it's the sum of 0 plus the derivative of this one, right? Okay, the derivative of 1 is 0. So we have 0 plus, now what's the derivative of this? So when you take the derivative of an exponential function, you multiply by the derivative of the exponent. And this exponent has a derivative of negative 2. Okay, so the 3 can stay here. So we have 3 e to the negative 2x times negative 2. And I didn't leave much room, but of course there's a dx here, the differential dx. So what does this become? It becomes negative 6 e to the negative 2x dx. Negative 6 times e to the negative 2x dx. And so you can see that this substitution is going to work because right here I have a multiple of du. That's how you know that this substitution works. So let's come back over here and figure out exactly what we have. So again, this is u to the 4. So we have the integral of u to the 4 because we called the bracketed stuff u. Now what is this? Is it exactly du? No, it's not exactly du, but it's close. It's negative 1/6 times du. Okay, so it's negative 1/6 times du. We like to put the constant part there out front. Okay, so again, we have the integral of u to the 4, and this part is negative 1/6 times this part. Negative 1/6 times du. Okay, now how do we integrate u to the 4? Well, it's not a transcendental function, it's just, you know, your straight up integral that you learned in your last math class. And we wrote it here last day. Okay, so u to the n, but in this case it's u to the 4. We have u to the 4, so it's 1/5 u to the 5 plus c. So we have negative 1/6 multiplied by 1/5 u to the 5 plus c, just like that. So this is now negative 1/30 u to the 5 plus c. And last step, we need to replace u with the original binomial. And there it is. There's the final answer to our 8th example. Okay, so I think we did 10 examples in our lesson yesterday, and now we've got 8 more examples. That's 18 in total thus far for your reference. Please make sure you are working on the problems posted for you in Blackboard. Okay, let me know if you have any questions. Thanks. Have a good day.